clock is ticking. We're on.
Good. I don't care.
With our big class here.
Yeah, not really.
8 dedicated students.
Okay, not so much dedicated. I'm tired. Not so much dedicated. We're going to bed.
Okay, you'll notice that I went to extra effort to emphasize the word solving here. Anybody happen to notice what the instructions were on your previous assignment? They were simplify, simplify, simplify. Yes, it's recording.
I know that.
Yeah, warn people before they sleep.
Okay, there's a big difference, and now you can work these problems based on whether it's a simplify problem or a solve problem.
Is solving easier?
In my opinion, solving is easier. Okay, when you simplified, was there an equal sign in your problem? No. When you solve, there's going to be an equal sign in it because we are actually trying to solve for x. Okay, and there's a big difference then. Because we have an equal sign, there's stuff we will be able to do when we solve that we're not allowed to do when we simplify. Okay, when you simplified, you had to make common denominators and keep them. I should say make and keep common denominators. Let me rewrite that. When we solve, we're going to get rid of the denominators completely. When we solve, we're going to get rid of the denominators. It's going to be better, trust me. Okay, when you got done with a simplified problem on your assignment, what did most of your answers look like? They still were expressions with variables in them, right? So when you answer one of these, you get an expression usually with variables. A few of yours simplified down completely to a number or even to 0, but most of the time you're left with some simplified version still has variables in it. When you solve, what do you get for an answer when you solve equations? You get numbers. When you get done with these babies, you're going to have x equals 4, x equals negative 7/3. You're going to get x comes out to a certain number. You're going to solve. Big difference. Okay, so you've done this before. In fact, back in August, you solved problems like this. They contained fractions. How did you solve an equation like that? We got rid of the denominators by doing what? We multiplied by the common denominator, and because we were multiplying it by both sides, it's legal, keeps the equation balanced. So yeah, we said, okay, we're going to take this whole crazy thing times 21. And so when you did that on the first fraction, the 3 canceled into 21, and you were left with 7x. When you take 21 times the next fraction, the 7 cancels, yeah, and you get 3x. And then, did you have to take it times the 2? Yes, you do. You have to take it times every term, whether it's a fraction or not. So if you take 21 times that, you're going to get 42. We're working with fractions. Seriously, you think you're going to get non-fraction answers very often? You can hope. It happens occasionally, but you're going to see a lot of fractions. So if I add this up, 10x equals 42. I divide by 10. I could suppose on this one, since it divides evenly, I suppose I could live with 4.2. Don't give me decimals unless it's exact. I would prefer you just reduce it down to 21/5. That's the kind of answer the book's going to give you. They're not going to kick them to decimals. That's a 5. Sorry. I'll try to make it. So, you solved one. Okay, only thing I'm going to do differently here is I'm going to give you variables in the denominator. Here we didn't have any variables in our denominator. You're going to work it by the exact same process. Exact same process. So it's really not that bad. All right, let's go for something with pizzazz and excitement here. If I gave you x plus 5 over x cubed plus x squared, and I said minus 2 over x squared minus 2x equals negative 3 over x squared minus x minus 2. And you think, oh wow, that's a lot of x's. Here she goes again. Okay. First thing you need to do before you think, we're going to times through there, we're going to cancel all those fractions. We're going to get rid of every denominator in that whole thing. But before we can get rid of the denominator, we have to figure out what the common denominator is that we should multiply by. So this is the same thing you just did on your last assignment. How do I figure out what the common denominator is? Factor all your denominators. So how can I factor this first one?
Take out an x squared.
Okay, take out x squared will leave me with x plus 1. Okay, what factors the next one? Take out an x, which would leave me x minus 2. And then the third one's a nice ordinary trinomial. So that's going to be minus 2 and plus 1, I believe. All right. So, and actually, we're making a list of steps here as well. So the first thing you're going to do is factor your denominators. Okay. And then there's this extra little step here we have to do because we're doing fraction action. And personally, this is a step I am very good at forgetting to do, as are usually many of my students. No, because I need a minus in the middle, so I need a negative 2x and a positive 1. Yeah. So I guess I could make that show up a little better there. That is a minus. Okay. What do I mean by check for excluded values? Okay. What's the one number you can never have in the denominator of a fraction? 0. You cannot divide by 0. So you have to stop and ask yourself, are there any numbers that would make me divide by 0? If this x equals what number is x squared? If this x squared, what number would I have to put in there to make it equal 0? 0. So therefore, when we get done, 0 cannot be an answer to this problem because it would make us have division by 0. You can't ever divide by 0. It's undefined value.
X can never equal 0.
So if we get done and x equals 0 comes out as an answer, we have to throw it out. Not allowed.
Can it ever be x equals 0?
On this problem, it cannot be.
Just this one problem?
On this one problem. Yeah. On some other problem, yeah, entirely possible. Okay, look at every factor. X plus 1, what would make that equal 0? A negative 1. So, okay, that one's also thrown out for this problem. You need to write them somewhere, yes. What's the excluded value? They're excluded. We can't use them. Okay, the x is going to also be then a 0. We already got it. What makes x minus 2 equal 0? 2, positive 2. So we can't have that one either. And then are there any new factors over here that we haven't seen before? Nope. So those three numbers cannot be answers on this problem. If we get done and one of them is an answer, we have to throw it out. All right.
What happens if we have one of those just one solution then?
If you end up throwing them all out, yeah, you have no solution, and that is possible. It doesn't happen real often, but it is possible. Okay, now, here's the fun part. I want to not have any fractions. I want to get rid of the fractions completely. The same way we got rid of all the fractions over here by multiplying by the common denominator of 21, we made them all cancel. You're going to do the same thing over here. You're going to multiply by the common denominator and get rid of all the denominators. They will cancel. Hang on a sec. I got to... Hold on. Yes, it is. Okay, so you just said my common denominator was what?
X squared x plus 1 x minus 2.
Okay, why not x cubed?
Because we don't only have x squared.
Well, because this is the problem I always have. People say, oh, I got an x squared here and an x over here. That makes 3 x's. No, no, no. It's the most in any one fraction. The most we have for x's in one fraction is x squared. So, yes, you are correct. It is x squared. Okay, there's only one x plus 1 in any fraction. And there's only one x plus x minus 2 in any fraction. Okay, so now, I'm going to write this out on every single fraction. You don't have to, but at first I think it helps people. When I take that times this first fraction, when I take it times x squared, x plus 1, and x minus 2, what's going to cancel? X squareds are going to cancel, aren't they? X plus 1s are going to cancel. So, eat up one extra line of paper and save yourself a disaster. Write down, what do I have left?
X minus 2.
And
X plus 5.
I have the x plus 5 left and the x minus 2. So those are the two terms I have left. I'll come back and FOIL them together later. Right now I'm just worried about canceling my fractions. So then, if I take this next one times x squared, x plus 1, and x minus 2, what's going to cancel on the next fraction?
1x and then the x plus 1.
1x and the whole x minus 2 quantity. So what's left?
2x.
A minus, a 2x, and
2x plus 2.
and an x plus 1.
What?
The x I canceled one of the x's. The 2 that was already there is left. The x is left. The x plus 1 is left. You got to look at what's left on the original fraction as well as what you were multiplying by. Okay, and then that equals, do it again times the third fraction. If I take this third fraction times x squared, x minus 2, and x plus 1, what's going to cancel there? Yeah, all the big quantities, and so what's left? A negative 3x squared. And to that, you no longer have any fractions, which in my opinion now makes this infinitely easier because you aren't doing fraction action anymore. This is now just plain old ordinary solve for x. So, what is it the algebra screaming at us to do?
FOIL?
Yeah, we're going to put, but actually let me add a step here. Write down the terms that are left after canceling. Then worry about multiplying it all together. People don't want to do that step. They start trying to multiply it all together when it's all squished up there and they can't see what they're doing and then they make mistakes. So now then we're going to multiply and combine our like terms. Okay, so I'm foiling the first one. No big deal. X squared minus 2x plus 5x minus 10. Okay, on the second one, I'm only distributing, but what am I distributing? More than that. A negative 2x. You must distribute negatives. They're your number one enemy on this. They'll get you. Watch the negatives. Distribute them. So yes, that's negative 2x squared and negative 2x. And then, of course, the right-hand side is just negative 3x squared. Yeah, I know. I've been watching my time here. So, combining terms on, I'm going to add up all my like terms on the left-hand side. X squared minus 2x squared is negative 1x squared. And if I add up all my x's, 3x minus 2x would be 1x. And then I have a minus 10. Okay. What do I want to do to finish solving this? Yeah, you want to get it all on one side. You want your x squared to be positive. So in this case, it works to add 3x squared, and we're going to have to pause.